Solar systems begin in dusty gas clouds called nebulae that are found between stars. The dust is composed of elements like iron and carbon. Nebula gases include hydrogen and helium. Within a nebula, dust particles collide and stick together to form larger particles. This process is called accretion. The particles grow from pebbles to rocks to boulders. The larger particles are called planetesimals. Rocky planetesimals near the Sun grew by accretion to become the rocky planets Mercury, Venus, Earth, and Mars. In the colder outer parts of the solar system, frozen gas is accreted to rocky cores to form the gas giant planets Jupiter, Saturn, Uranus, and Neptune. Nicolaus Copernicus was a mathematician and astronomer. He proposed a model of the universe in which the Sun, not the Earth, is the center of the universe. This is known as the heliocentric solar system. This was a radical idea at the time. Through his observations of the movement of the planets, stars, and Sun, he showed that the Earth revolved around the Sun, not the other way around. Prior to Copernicus, it was believed that the Earth was the center of the universe. This is known as the geocentric model of the universe, an ancient model proposed by the Greco-Roman mathematician and astronomer Ptolemy, also called the Ptolemaic system. Tycho Brahe was an astronomer from Denmark. He is known for his very accurate astronomical observations of the stars, planets, and comets. He was interested in creating more scientific instruments to aid in his studies. Brahe combined Copernicus's use of mathematics with Ptolemy's philosophy about the universe and created his own theory, known as the Tychonic system. Brahe showed that the Moon orbits the Earth. He also showed that the planets orbit the Sun. He did make a mistake, however, when he concluded that the Sun orbits the Earth. Tycho Brahe is the last of the important astronomers that are known as the naked eye astronomers. This means that their observations of planets and stars were done without the aid of telescopes. Johannes Kepler was a German astronomer and mathematician who made an important contribution to scientific thought with his 3 laws of planetary motion. He was the first to study astronomy as part of mathematics and physics. His work improved Copernicus's theory of a heliocentric or sun-centered universe, showing mathematically why planets' speeds varied as they traveled around the Sun. Kepler's first law of planetary motion states the orbit of a planet is an ellipse with the Sun at one of the 2 foci. Kepler's second law of planetary motion states a line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time. Kepler's third law of planetary motion states the square of the orbital period of a planet is proportional to the cube of the semi-major axis of its orbit. The orbital period is the time it takes for a planet to travel around the Sun once. Galileo Galilei was a genius scientist, artist, and inventor from Italy. In the field of astronomy, he supported Copernicus's theory, known as the heliocentric solar system, in which the planets move around the Sun. This was a controversial idea at the time because the accepted theory was the geocentric system, in which the Earth was believed to be the center of the universe, and the Sun and planets revolved around it. Galileo was one of the first astronomers to use a newly invented instrument, the telescope, to study planets and stars. He eventually made his own telescope that had a magnification of approximately 30x. His Galilean telescope had 2 lenses. the telescope would quickly become a valuable tool in advancing our knowledge of the universe. Using his telescopes, Galileo studied Venus, Saturn, and Neptune. He recorded that Venus had phases, similar to the phases of the Moon, which proved Venus rotated around the Sun. He thought the rings around Saturn were planets. He briefly observed Neptune, but thought it was a star and not a planet. In addition, he studied the Milky Way and sunspots on the Sun. He also used his telescope to identify mountains on the Moon. The Sun is a massive burning ball of gases held together by gravity. It is primarily composed of helium and hydrogen gases. The Sun has three main layers: the core, the radiative zone, and the convective zone. The Sun's atmosphere is made up of the photosphere, chromosphere, and corona. The core at the center of the Sun produces the Sun's heat. This energy is produced by hydrogen nuclear fusion reactions. During nuclear fusion, two or more protons fuse to form helium, and large amounts of energy are released. Energy produced in the Sun's core is carried to the Sun's surface in the form of light energy called photons. This energy moves from the core into a very dense radiative zone. It can take thousands of years for the light energy to move through this layer and into the convective zone. The outer layer of the Sun is called the convective zone. Hot gases in this layer rise toward the surface, where they become cooler and denser. The gases then descend back into the Sun. This circulating movement is called convection and is similar to currents in the Earth's mantle. The photosphere is the inner layer of the Sun's atmosphere. This gaseous layer is thick enough to be visible. When we look at the Sun, we are seeing the photosphere. Just beyond the photosphere is a thin layer called the chromosphere, which has a reddish color. The chromosphere can be seen during a total solar eclipse, when the Moon covers the Sun. The outer atmosphere of the Sun is called the corona. It extends for millions of kilometers beyond the Sun and is composed of gases. It can only be seen during a total solar eclipse. Sunspots are cooler, darker areas of gas on the Sun's surface. Cooler gases emit less light than hotter gases. These areas are caused by the Sun's magnetic field affecting the convection heat. Scientists have discovered that the number of sunspots varies over an 11-year cycle. Solar flares are enormous areas of extreme temperature on the Sun's surface, caused by magnetic fields. Solar flares typically occur near sunspots. When a solar flare erupts, streams of charged gas particles extend thousands of kilometers into space. The distance between the Earth and the Sun is approximately 150 million kilometers, or 1 astronomical unit, AU. Scientists use astronomical units to measure and describe distances in space. Another measurement is called a light minute, which is the distance light travels in 1 minute, or approximately 18 million kilometers. The dimensions of our solar system are vast. The 4 inner planets are much closer to the Sun than the 4 outer planets. There are numerous orbiting comets found beyond the planets in the solar system. The 4 planets closest to the Sun, Mercury, Venus, Earth, and Mars, are grouped together as the inner planets. They have rocky surfaces and are often called the terrestrial planets. These planets are small and closely spaced as compared to the outer planets. Mercury is the smallest planet, located closest to the Sun. Mercury revolves on its axis very slowly. A single Mercury day is about 59 Earth days long. Mercury does not have any moons or atmosphere. Its surface is covered with craters. A magnetic field suggests that it has an iron core. Venus is the second closest planet to the Sun. It is often called Earth's sister or twin planet due to similar composition, gravity, and size. Venus rotates very slowly in a clockwise direction called retrograde rotation. Similar to the planet Mercury, Venus does not have any moons. Venus is surrounded by a very dense atmosphere composed of carbon dioxide and sulfuric acid clouds. Due to the greenhouse effect, Venus has the hottest surface temperature of any planet. The air pressure on Venus is 92 times that on Earth. Craters and active volcanoes cover the surface of the planet. From a geologic perspective, Venus is considered a young planet. The Earth is the third planet from the Sun. The Earth's distance from the Sun allows for moderate temperatures that keep most surface water in liquid form. The presence of liquid water and an oxygen-rich atmosphere make Earth suitable for millions of living organisms. Mars, the fourth planet from the Sun, has 2 moons. A day on Mars is slightly longer than a day on Earth, and it takes about 687 days for Mars to revolve once around the Sun. Space probes and rovers have successfully gathered much information about Mars. Mars has a very thin atmosphere composed primarily of carbon dioxide. The surface is cold, dry, and dusty, with frozen ice caps found at the poles. Landforms and rover samples indicate that in the past there were large amounts of liquid water on the surface. Mars has a volcanic history, and the largest volcano in the solar system, Olympus Mons, is found there. The outer planets beyond Mars are the gas giant planets, Jupiter, Saturn, Uranus, and Neptune. They are also known as the Jovian planets. These planets are much larger and spaced further apart than the inner planets. They are primarily composed of hydrogen and helium. Jupiter, the fifth planet from the Sun, is the largest planet in the solar system. Although primarily composed of gases, its magnetic field indicates that it may have a rocky core. It has a giant red spot that is actually an enormous storm in its atmosphere. There are 64 known moons that orbit Jupiter. Saturn, the sixth planet from the Sun, is the second largest planet in the solar system. Winds can blow as fast as 1,800 kilometers on this planet. Saturn's rings are primarily composed of ice particles with some dust and rock particles mixed in. There are 62 known moons that orbit Saturn. Uranus, the seventh planet from the Sun, is the first planet to be discovered with the use of a telescope. Its cloudy atmosphere is primarily made of helium and hydrogen, but also has higher concentrations of frozen ammonia, water, and methane. Uranus is sometimes referred to as an ice giant. This planet has 2 sets of rings and 27 known orbiting moons. Similar to Venus, Uranus spins on its axis in a clockwise direction called retrograde rotation. It also has a rotation axis that is tilted almost parallel to its orbital plane. This makes it appear that Uranus is rotating on its side. Neptune is the furthest planet from the Sun. This gas giant is similar to Uranus in that it has a higher amount of frozen gases like methane, water, and ammonia, and therefore it is also called an ice giant. The highest known wind speeds in the solar system, measuring up to 2,100 kilometers per hour, are found on Neptune. 13 moons orbit Neptune. A comet is a small body composed of rock and ice that orbits the Sun. A comet's tail of ice particles can stretch for millions of kilometers behind it. Comets originate in the outer regions of the solar system and have a wide range of orbital periods, up to 1,000 years long. Scientists have identified thousands of comets, but this is just a fraction of the total number that exist. Asteroids are irregularly shaped rocky bodies that circle the Sun. They are found mostly in an area between Mars and Jupiter called the asteroid belt. Asteroids range in size from quite small to 100 kilometers in diameter. There are over 500,000 known asteroids. Meteoroids are smaller pieces of rock that have originated from asteroids. A streak of light, called a meteor, is seen when a meteoroid enters and burns in the Earth's atmosphere. When a meteoroid strikes Earth, it is called a meteorite. Meteor Crater in Arizona shows the impact and size of meteorite collision. Up until 2006, Pluto was considered the 9th planet from the Sun. After intensive studies, a group of international astronomers concluded that Pluto was actually a dwarf planet in a region called the Kuiper Belt. Asteroids and other planetesimals are found in this far distant region of our solar system.